Welcome back. We're doing for loops in MATLAB part 2. Continuing where we were before, we've got the cracks data, but we've now added a second row to it. Take note of that. Now, our goal is to add +3 to each of the items in the second row, which means we need to access the index of the second row itself. To do that, when we call a generic variable, parentheses, you call the row and the column. Alright? That's why in our syntax here, we're calling cracks 2, I. That calls the second row and the ith column. Okay, and we're going through I equals 1 through the length of cracks, which is going 1 through the 5 values in each row of cracks. Okay, length gives us the larger of m by n of the matrix, so it's the larger value of either your column or your row. In this case, our columns are greater because we have 5 of them. So length of cracks returns 5, I is 1 to 5. We start going through. We're calling a new variable to be saved, and we're writing over cracks. Okay, we're just going to write over the current values, and we're calling the value that's there right now that exists in the cracks matrix. So this will be 2, 1 for the first I, and that'll be 5. Take that 5, add 3 to it, we should get 8. Okay, and then we do this, cracks 2, 2, which will be 1, add 3 to it, we get 4. As we run this, we see here's the original cracks up top, 51200 on the bottom. That becomes 84533 because we added 3 to each of those values using this for loop. Moving on, next example. We added another row to cracks, keep that in mind, and now we have a 3-row by 5-column cracks matrix. And let's say we want to go through and output every variable in the matrix, right? If you can output it, you can do anything else with what you want as well. Cracks I, j is going to be our output. Let's start from the top, and we're going to call 2 for loops within this section. First for loop is going to be 1 through m, and m is going to be the number of rows, and we're going to access that by calling size of cracks. To show you this, size of cracks gives you this is the cracks from before. Let me give you the new cracks so we can assess that properly. There, 3 and 5. 3 is the number of rows, 5 is the number of columns, and you can save these values to m and n using the syntax I have shown here. Thus, we can start by going for I equals 1 to m, so we're going through the number of rows, internal for loop, okay, it's called a nested for loop, or for loopception, whatever you're feeling. This internal for loop will go j, new index, right? We don't want to use the same index for the 2 for loops. New index j goes from 1 to n, the number of columns. As we step through this, big for loop, I is 1 to start. Small for loop, I is still 1, but now we define j to also be 1. And then this small for loop will run in itself. So j was 1, j is 2, j is 3, all the way to j is 5, which is what our n is. And all that time, I is 1. Then we go big again, and we go to the big for loop. I becomes 2. Small for loop, j 1, 2, 3, 4, 5. Big for loop, I is 3. Come in, j 1, 2, 3, 4, 5. Big for loop, I is now 4. That's how this is running. Okay, so the cracks I, j will start out as cracks 1, 1, 1, 2, 1, 3, and that'll then give us all the items in the first row together. Okay, then I changes to 2, 2, 1, 2, 2, 2, 3, 2, 4. We get all the elements in the second row, and these are just outputting. Right, this command just outputs, and here we see 2, 4, 1, 0, 2 is exactly the same of our first row, calling out all the columns. Great. Next, here we've got a weather prediction. The weather variable is a 7-day forecast. 0s means it's sunny, 1 means it's rain, and we're concerned about the rain. We're going to go through a for loop, and whenever we encounter a 1, we want to change the next day to 2, which indicates it'll be partial showers. All right. So we go 1 to the length of weather, right? This will give us our 7, so we're going 1 to 7, each of the 7 elements in weather. We've got a nested if statement, so a nested conditional. We did a nested for before. Now we're doing a nested if. If the weather is rain, use an equal to do the comparison if, or the comparison equal to. If the weather of a certain day, weather I, is 1, then we're going to change the next day, weather of I plus 1, to be 2 to indicate the partial showers. As we roll through this then, we have the original weather on top. We've got 2 1s in there. In this new weather variable, we've got 2's that follow the 1s because we're indicating partial showers to follow the rainy days. Moving on here. This is the same exact approach as above. In fact, we have some of the same syntax here to start, but instead, we're going to also add another variable to the mix, which is going to be surface water. And this is just to show that you don't have to stay within your one variable that you're looping over. You know, we're looping over length of weather, but the for loop doesn't have to only be tied to weather. You're just using length of weather. It's an integer. It's giving you an integer. You can do whatever you want from there. Same way when you call weather I plus 1, right? That's just an integer in there. You can call any value you want. It doesn't have to be tied to I. I mean, granted, you're using for loops to get access to that I, but it's code. It's open. You can do what you want. So here we've added this extra surface water variable to keep track of surface water based on the different rains. So when I is 1, that day is going to be a surface water of 10. We've kept the I there in the surface water. And the following day, the I plus 1th day, is going to have 5. If we run this, we can just tell that we've got 1s correspond to 10s, 2 into 5s. But what happened at the end? Why don't we have a value at the end here? Well, the last value in weather is 0. And when we hit this conditional statement here, if weather I is 1, well, it's not. So we never get to add these last few values in the surface water matrix or array. And that's fine. We don't need that. If you wanted to make sure you had it, you would add a surface water vector to start and define it as all zeros, and then you would populate that along the way. And that would give you just a little extra because you started out with surface water and then you changed values as we went through, and that's what gives you the extra 0 at the end. Now there's two main issues that are going to happen when you're calling out your for loops and when you get errors, especially when indexing. The first is that you can exceed the array bounds, which means it doesn't exist, or you might end up calling a 0 index or a negative index, and MATLAB doesn't allow that. MATLAB indices start with 1 and go upwards positively. You can't go to negative values, and you can't call values that don't exist. Here in this first example, we've just got basic data, and we're going through the length of the data, and we're going to add the current value, the ith value, to the value before it. All right? If we try to add this, we're going to get an error because it says the indices have to be positive integers or logical values. In this case, when I is 1, we go through, we have data 1, great, that's 20. Data I minus 1, well, data of I is 1 minus 1, that's data of 0. Well, data of 0 doesn't exist, hence we get the error, okay? You'll need to change that, either your indice or you can change what you're looping from. You can go 2 through length of data, and it'll actually run here. And I've got the output suppressed, but if we open that up, then it works fine. And you start off with data 2 plus data 1. One way to fix your problem. The other issue we're looking at is when we exceed array bounds. Okay, in this scenario, we're going 1 through the length of data, but we call this data I plus 1. Okay, I plus 1, when we get to that 7th item, is going to be calling data 8. Right? 7 plus 1 is 8 at the end here, and we're calling data I plus 1. That becomes data 8. Well, there's not an 8th value in data, so we can't call that value out, right? And that's where it gets a bit tricky. You might have to add either an extra value to your data or adjust your indices. You could do, 1 through length of data. You could do and add some extra stuff. You could be clever, work it out. But I would likely just change this to a situation above to end up going backwards 1 value and accumulating your values as such. Hope this helped you guys. Hope you got some insights into MATLAB for loops. Good luck up there. Have fun. Be clever. Like and subscribe. Take care. Bye-bye.